Hi, everybody. Welcome. Today is Thursday, November 5th. I'm Kate with the Creative Coast, the Director of Programs and Communications. And today we're here with David Zendzian of VMware Tanzu. And he is an executive on the Executive Advisory team as an executive technical advisor for compliance and security with VMware. And we are so fortunate to have him here today. He's going to talk about security considerations in a modern container application life cycle. So without further ado, let's turn it over to David.
Hello, and hopefully this is not a very long conversation, so I'm hoping that we can even turn it into a dialogue for those who ever join. And I'm using a new tool, so bear with me for a second as I try to get these parts configured on it. I was showing as we got started this. Let me get down here so I can give you some space to see our presentation. But let me get this out of the way. Go away now. So as was mentioned, I'm with VMware, but I'm here local. I live in Bluffton, and I try to do as many things as I can in the local community. I've been working in the tech space in startups and with modern applications and infrastructures for a very long time in the area. Ended up at Pivotal last year, who was acquired by VMware in what's called the Modern Application Business Unit. And what we do is we help enterprises look at the way they produce software, the way they produce the applications that run their businesses, and help them modernize them and look at the ways that they can run in containerized spaces and large clusters around the globe with the new tools that are available. And one of the conversations I have, actually the primary one I have, is I talk to customers around the security and compliance. So what's changing in the security side? And what's different because we're doing containers, and how are the tools available? This can be a quick little overview of the concepts and ideas. I'm giving examples of what VMware can do, and I've got some partners we work with who are in this space, and I'm more than happy to help talk to anybody. So come join the Savannah Slack, or reach out to the Creative Coast, and we can get other Zoom meetings together and kind of just do whiteboardings and talking about this. I actually was mentioning also I have a whiteboard I do with this that goes into actually discussion and making workshops around making this work. But enough about me and the intros. If there's any questions, I'm more than happy to turn this into a discussion on any of the topics. Just feel free to either ask questions, or if you're able to, you're welcome to unmute and ask your questions. That way we can have a whole discussion around it. But inside applications, what's happening is this whole changes happen over the last 5-10 years is we've gone to an agile lifecycle. We're doing more rapid development. We're doing more integrations into other services. And the real big changes as we're doing that is to make that development happen easier is you're taking monolith software and really modularizing it, making it into microservices and components that are smaller pieces talking to each other. And that changes the way you look at security in these models. So now you can do security at different points. It doesn't make sense to have some code written and then have a team they get sent to, they can pen test it and come back. When you're doing things in microservice space, you might only be changing a component of a piece, and testing that is a whole different model. So what I'm gonna do here in this presentation is talk about this whole modern lifecycle. This is something I'm sure hopefully everyone's familiar with, but this is the idea of how the whole process works these days in doing the creation, testing, release of software. And each one of these areas, there's an impact on security, and I do focus just on security, but if someone wants to have discussions on the coding side, we can definitely talk about that, but I'll focus on the parts of this that change in security. One of those things I think is a really important thing to do is if you're able to, and you have security experts or security teams in your companies, is I'm a firm believer in the idea of a balanced team. You can't have your agile team who's working on the design of the software based on the business needs, then creation of that and testing and release of it, and then only fit security in the releasing part of it. You need to really have security in the whole process of it. Oops, wrong direction. So how do we actually go from having an idea for this process? How does it go from design and out to the end users? And the whole goal of what we're trying to go here is take this idea from the business who comes up with a product idea, gets it created, designed, and released into an eventual place where a user is able to consume it. This is really the goal of hopefully most of the applications. Now sometimes it changes a little bit. It might be actually machines and services talking to each other, but the idea is really we're releasing these parts together. And when you're doing this, I mentioned having the balanced team. You have to be thinking about when you're creating your software, what really is the end results? What do you need to be concerned about? The security, from a security point of view, are there controls and governance requirements? Do you have PCI? Do you have healthcare? Do you have any government regulations? Do you have any financial considerations of things across borders? Are you doing anything with taxes, or are you going to be dealing with publicly traded companies and stocks and financial data? There's all these different things that as you're working on developing the products, your developers and your product managers may not know. So you need to really have the security in the beginning talking about this. But also, things are changing now. Is we're no longer taking and creating code that is copied over to a server and run as a Java file on a Tomcat server, and you're trying to maintain fleets of servers with that. You're actually doing things where you're bundling these up into containers and deploying them into large clusters out in Amazon or on-prem in Kubernetes environments. And because of this, you really need to keep in mind how are you actually doing preparation for the application in that different space. If you're looking at typical security events that happen in a life cycle of an application, something's going to get hacked sometime. Something's going to happen somewhere. You have to do investigations. In the old world, you have to do forensic investigations through doing memory dumps and getting copies of hard drives and having people spend time going through and figure out how things broke. But in a Kubernetes space, when something breaks, Kubernetes just deletes it and starts another instance. It's no longer there, and there's nothing to do forensic work around. So that makes it a little bit more difficult to do instant response. You have to actually build the application so the application logs enough data so that when someone comes back in the future and tries to replay what people are doing, they have enough information to really understand how was the application broken, how did the people do what they did to the environment, and what was the end results through the logs and events that are happening through the entire environment. Something that can help with this is when you're developing user framework. I personally spent a lot of time in the past doing Rails. I think there's interesting ways you can do with that. But now that I'm with VMware, I've been working a lot with Spring and Steel Toe, and which are .NET and Java environments. Java has been around for decades. It has always been a great language that has great platforms. Spring is one of the most used platforms I've seen anywhere for doing microservices. The libraries and the tools around it for doing secrets management, for doing your testing. For when you're doing your testing, you can do not only your blue-green tests as you're deploying to make sure things are working, but you can also have circuit breaker tests. And as you're designing your applications, you have to make sure, how do you test and make sure it's released and has security in it as part of the process? And having the framework that can tie into doing the tests to make sure that connections, again, these are microservices. So they're gonna have connections between many different things, or connections to your credit card processor, connection to your database. And what happens in the application if your database goes away? How does it fail over? Some of the key environment controls that come out of doing the cloud native environment is you have what's called an immutable and ephemeral environment. But the applications have to understand that. If you have a Java connection where you create a database pool where you just connect the database and you expect that pool to always be there, what happens if you don't have a circuit breaker to actually make sure the application can handle a database failing over to another cluster or to another server if things change? So it really is a big consideration. And we've not even gotten to a point where we've even done any containers and deployed it. This is still in the consideration of how do you design it and build these things in. The next step when developers are going down this path is they're going to check their code into a repository somewhere. One thing in security you want to make sure you're doing, this is going to be on your traditional security path as well as your containerized space, is you want to make sure you can trust where the code is coming from. So you want to have some sort of code signing. So if you're checking in your code, you can actually, each developer has their own certificates. It's managed through so whatever process you have internally. A lot of enterprises will have key management or identity management programs that can tie together certificates to people. So when they're checking their code in, it came from that developer. There's no doubting the source of that code. Now that it's in the Git repository, something's going to happen to it. And you have generally your continuous integration pipelines, which will be building the application. This is where you'll have your Docker files, you'll have your configurations of defining what services come from, from the application dependencies. It's going to pull together base OS images. It's going to grab the runtime environment to the Java, the .NET, those various pieces. You're going to have to figure out how to actually tune and make this work in a consistent manner for your application across the containerized build. And it's also going to pull in third-party things. There's a lot of third-party libraries that your application depends upon. So I'm mentioning all these so you can keep in mind as you are working on, creating the container from your code. You're actually building the component that's going to run in the Kubernetes space. you have to keep all these in mind of how do you actually make sure the security is there. So if it's pulling in third-party libraries and tools, do you have an inventory of that? Do you have an understanding of what dependencies you have on code? There have been many different problems in the past. Just recently, NPM got hacked again. And these third-party libraries people are using are becoming gateways into their applications. So you have to know where your code is coming from. And your pipeline can do things like you can use a Sneak, or you can use various other source code analysis tools to actually check these third-party libraries. Look for open source licenses you shouldn't be using in commercial spaces. Look for vulnerabilities in NPM or Java libraries or .NET libraries that you're depending upon, or Ruby if you're using Ruby like I do in some places. So having your pipeline is going to be essential for tying in those security monitoring components, security scanning components. But one thing you also want to do is like what happens in the in the VMware, we have the build service, and what that can do is it actually helps when you're taking the runtime. So you're taking your OS, you're layering on your application, but the application needs to run in your either your Java or your Spring, or your Node or your .NET or whatever the actual runtime is. And there's a lot of tuning that usually goes into getting those applications running. So if you're going to run Java, what's your heap space size going to be? What's the best tuning needed to run in a containerized space where you're going to have thousands of instances that are all 1 gig versus hundreds of instances that are 20 gig. The tuning of that is really important. That's one reason why we have the build service, which came from the old cloud native build packs, and the idea that we can actually have the community and open source and commercial endeavors build actually better ways of actually building your application. So far what's happened is we've had developers who have created code, securely signed it in. You're using frameworks so that it actually makes easier for modularization and security components. Your pipeline is scanning code. You've built the OS on top of it. And then all this has to go somewhere. It has to be uploaded to something that's actually be consumed by your Kubernetes space. And that's going to be your registry. Harbor is one of the open source ones. There's a commercial offering from VMware. And what's nice about Harbor is it has built-in Trivy and other scanning interfaces. So you actually do vulnerability scanning of code as it's checked in. So once you've built your container, you might want to actually make sure you're constantly knowing, is that container have a new vulnerability? A container that you've built today might be good, but in 2 days there might be a MySQL library issue that all of a sudden you're vulnerable for, and you have to figure out how am I going to monitor and control using of these containers in my Kubernetes space. One of these things that Harbor does is when you upload your container, it'll actually scan these vulnerabilities. It'll give you reports, and you can even configure it so that you cannot copy images out of Harbor into your Kubernetes space if they have high or medium or critical or whatever level you want to set vulnerabilities. And what's nice about this is, say you're using an image for your application space, and then next week you have a large load that comes in, and you start adding new pods for your clusters, and those pods are going to download the new images. And if the image has a vulnerability, you can actually automatically prevent that from being copied out. But hopefully, knowing there's a vulnerability, it will be part of an automatic process to be replacing that. We don't remember that whole cycle earlier was an infinite loop of going through the different processes as you're building this. So by the time there's a Harbor notice of a vulnerability, your continuous integration pipelines should have already been looking for a new OS image, for the new build packs. And when there's new versions, your pipeline should automatically grab those new versions and already have a latest, newest version of your container uploaded to Harbor, so you can actually consume it and use it inside your containers. Now, some customers I work with, they're not comfortable taking the base OS itself. Like, they understand the build service, there's a lot of tuning configuration to make it run best in containers, but the actual OS itself, it needs to come from somewhere else as well. And you want to make sure that you are you're able to actually build your services, your OS that you're putting underneath the container in the runtime space is using an up-to-date actual OS. So say you're using like a Debian minimum or Ubuntu, or you're using a Windows container image. Getting the actual image itself, Docker Hub, one of the problems that I've run into with that is you might be using a Debian image, but they're only building that once a quarter, or when they get around to building the next version. It's not automated. It's not configured so you're getting the latest version. So you might be doing all you can to release your code fast. Your pipeline is grabbing the new build service and you're actually compiling things, but the actual OS side might not be the latest version every day or every week because it's out there. And this is where when Pivotal was bought by VMware. There's another acquisition called Bitnami. Some people may have been using Bitnami already instead of Docker Hub, but this is what Bitnami, which is now the Tanzu application catalog, can bring, is the idea that it actually provides the curated open source, OS, MySQL, the Debian, the Ubuntu, Postgres, all those things. They're updated automatically on regular, continuous basis. They're already doing virus scanning, so you can actually have, if you want to build your image in the build, in your continuous integration pipeline that's going into hardware, you can actually pull in from Bitnami or the Tanzu application catalog the actual OS, and you can have your pipelines checking to see, does the virus scan have anything to be worried about? Is there anything that comes out of the knowledge of, like, if it hasn't been updated in a week, should I be pulling from it? Should I create a ticket in your Jenkins that the OS image itself is over a week? So you can actually get metadata out of the catalog and determine your OS information. So all this is, again, observing the security and the use of the security in the environment. What happens now in the application is you already actually use it. So you need to actually get it out into your pipeline, your continuous delivery pipeline, which is going to connect to your on-prem, probably on-prem is only a couple options, but you can probably like the VMware TKG Kubernetes offering. You're going to be or in Amazon, or you can be in Azure or Google or any of the cloud providers that have Kubernetes, and your continuous delivery pipeline will tie to all of those. And through the rules you define in those, it'll actually connect up to the Kubernetes and deploy things. Kubernetes itself, hoping I can come back and have some great talks to folks who are looking at using Kubernetes or might be using Kubernetes. There's a lot to talk about in security in Kubernetes. There's pod security policies. There's open policy agent. There's the network policies. The idea that you're building applications and you can have strict control over who has the ability to do container creation, who has the ability to actually change and modify things and proper logging. I could literally spend hours and lots of whiteboards. We can dive into this. Any questions folks have about it, but the selection of what you're going to run your Kubernetes in makes a big difference. There's a lot of different things to consider how that works. I work with a lot of customers that are multinational banks. They're in the financial space in multiple regions around the globe, some of these folks have a need to actually have tighter controls around their infrastructure, their Kubernetes space. And the idea that they run into the problem with a lot of cloud providers is that you have no knowledge of what's happening on their back plane, their control plane. When you say that Amazon create a Kubernetes cluster, it just does it and it manages it in the back end. You don't have access to tune or tweak anything about that. Or the important thing for a compliance or regulatory based company is they have to monitor, are any of the actual control plane variables changed? Does the administrator have access when they didn't have before? Did it put things in different subnets? The actual control plane is a really important thing. And that's where I work with the TKG offerings at VMware just to really help people understand if you can deploy TKG in Amazon, you can control and monitor these things. So the security around your Kubernetes is most critical because that's actually what's talking to the world. And when I'm talking about application security, there's a lot of things people talk about in the Kubernetes space that are in the runtime security. How can you actually prevent and protect your application as it's being actually connected to in a runtime space? There's a lot of things that come into that. Carbon Black Cloud is coming out with new pieces of the Octarine interface, which will actually help you not only monitor your policies, make sure your policies are in good order for your applications, but also looking for runtime events happening within the application space. We have a lot of great partners. I've worked with Aqua Security. There's Prisma Cloud. There's a whole bunch of others that can provide container security, which do similar, like Harbor does the container scanning. They can all do the container scanning, but they can also do some runtime protection. So inside the Kubernetes space, the idea that if your application is running and someone hacks it, they're going to do a couple of things when they hack it. They're going to write some files to the file system and try to use that to run scripts and execute things to pull data out. They're going to try to take data from the system and upload it to different servers to get it out of the environment. And these runtime tools can prevent all of those sort of things. It can enforce dynamic monitoring of the actual connections on the cloud and say, oh, it's not supposed to connect to this Google server to upload things. It should be denying those sort of things. Or you can create a file, but you can't make it executable, or you can't create files. So it's great to have the runtime protections in that space as well. And I do have to bring up my favorite application security company is Contrast Security, because I think security really comes down to, in the end, the security in the application. That's what the tools that everyone is talking to in the world. And when you're actually being attacked, they're not attacking Kubernetes, they're attacking the application. So if you can prevent the application itself from being compromised, it really helps set the stage for tight security. Now, These are all kind of expensive tools. There's a lot you can get into. In fact, we could probably talk about some other things at a future Creative Coast session if people are interested in on the development side. There are ways you can actually approach securing applications that have some of these responsive things using open source and just time as a developer. So you don't have to buy commercial things, but if you can, there's some great tools there. I mentioned earlier the idea of the clusters and the policies. Managing this when you get a larger scale. Some of our customers can have thousands, if not tens of thousands of clusters, and trying to apply policies and manage them across the board is hard. That's where we have the VMware TMC, and you'll have other tools out there that are getting into the space of managing policies. And you want to be able to manage your policies both in your in-house data center. I have ESX here in my house. I've got a bunch of Ubuntu servers that they're doing clusters. And it doesn't matter what the Kubernetes cluster is, if it's EKS and or if it's in Azure. It doesn't matter. You need to be able to tie them into a way of managing this at scale and understanding how do you actually know what your policies are. What are the proper policies to have? Who has access? What network connections do you have? You can do a lot of that through YAML and manual configurations, but as you get beyond your initial stages, if you want to get your environment working to a place that has scale and the ability to work as an enterprise, you need to have the tools for that. Now, the backside of all of this, I mentioned earlier on, was talking about the security, the incident response, the forensics, and that ties into the observability of things. And this is the last thing I'm going to talk about on the inside of these systems before getting to the service mesh component. But on observability, there's two sides to observability. One is you actually want to observe your clusters, your applications, your services, make sure things are working like they're supposed to be, and having the tools to actually investigate root cause analysis, tie together events and correlations, and try to figure out how things are working together. To make that work, we have the Wavefront Tanzu observability. I shared on the Savannah Slack back during COVID some of the observability dashboards that were made for COVID. It's a really interesting tool. You can have millions and millions of events per second with real-time observability into it, and it's incredible tool. I can't even begin to go how cool it is. It's someone who used to manage and run data centers. It really is something I wish I had 20 years ago. But tying that into security, how do you actually look for events that are happening? If you're logging somebody is, submitting form data to your application, but they constantly, 20 times a minute are submitting invalid data on the form fields, and they're just constantly failing your input validation. How can you capture and identify that and cause the visualization, the spikes, and machine learning to actually look around that? So this is the, in my opinion, the critical part, both forensic analysis and the future of artificial intelligence and security monitoring. The idea that you're going to observe millions of events happening around your infrastructure, your pipelines, your code generation, your actual live applications running, and being able to make correlations and tying it together and having the ability to observe it is really going to be the key of the future. And the last thing I want to talk about here, and I realize we have a lot more time, so I'm hoping that there might be some questions, is what do we do as we're going forward? And you have a lot of microservices. If you actually built your application, so you have lots of microservices, how do you tie them together? How do you connect your clusters between multiple clusters? And a lot of people are using service mesh technologies to do this sort of thing. So in a security space, you want to make sure that if you're using service mesh, you're doing good authentication, using MTLS where possible to do full authentication. And if not doing that, you're able to communicate proper authentication and authorization for your services. So just because you're running microservices that talk to each other across an application inside of a Kubernetes space doesn't mean that they're all trusted to each other. You have to make sure, is the service authorized to talk to it? Is it talking in a secure manner? Is it now authenticated but then authorized to access and do the functions? Can it just read the data or can they write? So there's all these considerations you have to make sure as you're making these applications that they have all that thought together. And service mesh is really going to be what makes all that tie together and work in a good manner. Now, this is the steps that I've worked with a lot of companies as they're building their applications going forward. I'm happy to go into any depth or any questions on any of these. If there's any questions, I'm not seeing any out there. I know we had an hour today. I went through this kind of quick, hoping that we might have some questions. And if not, then we can just see where we go.
Lou, you have any questions?
Sorry.
I
I
dumped a lot of you on all at once, so I go
yeah,
in.
yeah, I turned my camera off because I was looking at the other screen to see your presentation. This is really beyond me, but it just ask some, I guess, rudimentary sort of a question.
Mhm.
So what I take in is the idea of containers. So you apparently you're working with the modularity of the software, right? So you can, but also you have to function in the certain environment like Kubernetics, and so so that means do you have to work with the client, from the ground up, meaning when they are, structuring their software, you have to come in, not just, it's not like a magic, you can just throw it in, so whatever you have, I'm giving you covered, right? So
It definitely is something that and this is something that the VMware has what's called the Pivotal Labs, which Pivotal Labs goes back decades. They actually helped Google originally come up with the ideas around Agile and how to do extreme programming. A lot of companies, the ideas of extreme programming, Agile development have been around for a while. There's a lot of program managers, a lot of Scrum leaders, a lot of people who are trained in doing this. So a lot of enterprises have teams who are doing Agile and rapid development. And they're just now figuring out, how do we put these components together? Some are more advanced than others. Some are more less advanced. For the customers who are really advanced, there's even tools that you don't have to do any of this. The flagship tool from VMware is called the Tanzu application service. Basically, you just take your code right here on Git on the left side, and you just say, go into your Git repo and you just say CF push, and everything else on this whole pipeline part is automated, and it automatically scales and pushes it out there. So there are top of breed tools to make this completely easy for customers. Those tend to be very expensive in an enterprise base. There are open source versions you can actually get and build yourself. Like Kubernetes itself is open source, Cloud Foundry is open source. But as a business, you need to have support. You need to have the ability to have teams help you use it. In the Kubernetes space here, the typical engagement with a customer who's going through the transformation, like say we're talking to a shipping company, they're a logistics company, and they've got, I'm only mentioning that because my history with Savannah goes back, back to the early 90s when I worked for a shipping and freight forwarding company. I would work down in the office in Savannah sometimes and down in the port. So it's near and dear to me. But if you have a shipping company and they have software that tracks the logistics of the orders coming in, what distribution point are they going to, when's the delivery time, what trucks do they have to go on to, how do you actually organize, does it go into the front of the truck, the middle truck, the back of the truck, is for making sure the truck is balanced and weighted, but also keeping track of what stops it's on to make sure it's easier to take off and not rearrange things. So all that software, imagine that's written for a company. They've had that out there for 20, 30 years that they've been running, but they want to start adding mobile apps so the truckers can have an easier integration into it. They want to have the ability to have a web interface so they can tie to partners and have an API so they can actually have customers submit data automatically, and they want to modernize. And this would be something where they'd come and they'd meet with the labs part of VMware, and we would help them understand, here's how you develop. We actually have teams that help you build your SREs. SRE is a term that came from Google on how you actually do the actual operations, the management of your clusters and building and running it. We have a whole SRE practice to help train people into that process. There's also a modern application practice that will take and look at these monolith applications and really go into the details of, is it Java? Is it a mainframe application? Is it written in Python from 15 years ago? And what needs to happen to it to actually modularize it, break it up, and make it into an ephemeral cloud native application. So it has those things like I mentioned earlier about having circuit breakers. So if a database connection goes away, the experience to the user is still transparent and allows it to be ephemeral and work in that space. So there's all levels of engagements. It all depends on the customers we're working with and where they are in their journey. This whole path to production journey is some customers are used to producing code on a regular basis. Some have actually third-party firms, like the company I used to work for that was a shipping company. We actually bought software from a third party, and it ran on, at that point, it was a microcomputer. It was a Microvax that actually ran part of it. But their model would now be the software producer is probably going to produce a container. So they will actually have the software company would have the development environment, their own pipelines, their own build service, and they'd have their registry, a hardware registry, where they'd have their software, and then the line be drawn here in the middle, where you'd have a customer who's going to have somewhere in Amazon, or they get an on-prem, Kubernetes cluster, and then they would have their own pipelines to pull from the software vendor and deploy it into their clusters. And that's another model I'm seeing happen into a lot of spaces, is tying those together. So you're seeing the software development firms going into container-based releases as well. And it makes it just so much easier. There's a part called a Helm Chart, which is a way of defining a set of variables, how you deploy an environment. It can define things like, you're going to have a memcache cluster, you're going to have your database clusters, and there can be certain kinds of database. You're going to have master and backup, and you can have a cron job service. You have a different microservice with a service mesh. All that's defined in your Helm Chart, and you can just take that from the registry with your containers, run the Helm Chart in Kubernetes, and it just takes and builds the entire environment, and then maintains the state of that. So as images are newly upgraded in the registry, the chart will then go and download it, and it's going to be tied into your pipeline. So the idea is you want to make sure that you are on the latest version possible. Something that came out of the old Pivotal days is a phrase that was the 3 R's, and the idea behind 3 R's were the idea that you're going to actually release often. If there's a patch, if there's a bug, if there's a vulnerability, if there's a new feature, you're going to get that out the door as quick as possible. That's why you're doing the agile and extreme development. You're not doing this big monolith where testing is hard and cumbersome. You're going to have it broken up, your application broken up into microservices, so that you can actually test and release a component much faster than having to test it. It's testing across the entire application, because it's no longer a monolith. So you're going to release it often. You're going to rotate your credentials and passwords out. You're going to make sure you don't have to have those, because exposing and making it so attackers can get your credentials. And then more importantly is you're going to do what's called repaving. The actual upgrade process. So within Kubernetes, within the VMs that run Kubernetes. So when you're looking at the TKG, the way that the actual system is managed as virtual machines and the Kubernetes clusters within them, you no longer are upgrading machines. In the past, we would use tools like Chef and Puppet and various other tools to actually maintain thousands of servers, and you just log into them once a week and do upgrades and patches and maintenance, and hopefully they never went down because people were worried about them. The idea now is you want to, as quickly as possible, delete those machines, because what happens in the Kubernetes space and the TKG and the management of the VMs of the Kubernetes is when a new version is available, the actual orchestration, the automation in the back end of it will create a brand new server, reconfigure Kubernetes to the environment. So you get a new OS image. So it's like a firmware for an appliance. You get a new version that comes in. It's just like the containers. You take it, copy it over, builds the VM, builds the Kubernetes, migrates your container applications to the new system, and then it just deletes the old one. It doesn't even bother upgrading anymore. So you're actually rotating the services out of the environment. So it's a completely different model of working. And I know I kind of babbled a little bit there. Is that is that helpful in any way? Is that any more questions or thoughts of things you'd like to know about?
It's great. It's great. You still have more in your presentation, right?
No, this is pretty much the end of it.
Okay.
The idea really is I wanted to it's hard. I can go back to any part of here and dig into things if you want. But I do apologize.
Yeah, no.
I had to do it quickly, so my mind is on the fast track talking about it, because I save time to talk because there's so much information in this. And if you are dealing with anything with development, and you've not gotten to a point where you're doing automation on it, it's a lot to absorb. And I want to make sure that there's time to have these conversations, because it's much more fun to talk about it and do it than to just get a presentation. So that's my opinion on life.
Hey, David, I have a question. So is there a number one takeaway from this, like a quick summarization that you would say, like the most important part of your presentation that you would stress? It all seems really important. Like you said, from the start, security should be involved from the start, but I'm just curious if there's a certain area that you would say, I don't know, definitely don't bypass.
Well, from a security point of view, so all of this, if you're going to be doing anything in a modern, automated pipeline for an application deployment, all of this is going to happen in some form or another. There's no way around getting this, you're going to have something out there doing all this. Now, from a security point of view, every single part deals with security. If you don't have security experts, reach out to, there's people in the community who would love to help. There are businesses who can come in and help. So if you're actually working on a commercial enterprise, there are plenty of people who can come in and help. But you really want to, from the very beginning of your thought process, think about what are the security ramifications of what I'm doing. Do I live in a governance space? Am I doing credit card data? Is there PCI involved? Am I dealing with healthcare? Is there any sort of PHI information for actual people's information you might be dealing with? The privacy laws in America are changing as much as they are in Europe, and just having people's home address can be a concern. You know, if someone comes and asks to purge stuff and they live in California, it's different than if they live in Savannah or South Carolina. So understanding what the security realms your business lies under, and then how each of these areas that you're going to work through are impacted by security. So it's easy to walk in there and say, we can let's write some scripts and make this happen. We'll go back and add and patch things after the fact. It's harder to do that in reality. It's life is so much easier if you think about it, you plan it, and you include those steps in every step versus trying to come back and fix it later when you might break things when security gets involved. That's probably the biggest thing, and that was more than a 10-second answer.
That's perfect though. So you said something about hacking, and I think for people like me who I'm technical to a degree, but when we get into stuff like this, it's a little beyond me as well. And but good information, of course. But you mentioned hacking, and generally speaking, you said you're going to get hacked at some point. Like, do you have stats on that? Like, how often are we getting hacked and we just don't know it? Like, how concerned? We've seen all these documentaries lately on security and the importance of not putting your data out there, being careful with what you do with your information online. But I'm curious your thoughts on that and the kind of stats on hacking. How much is going on that we don't know about, and how much are you protecting us from?
So it's an interesting conversation around security. There's probably the best analogy to make it easier to understand is in this wonderful climate we've had for the last 6 months, the idea of having these bots out there doing all this tweeting, all this changing information, all this they're using artificial intelligence to generate fake people faces, to create fake Facebook profiles, to post things to incite people on various political affluences, and just thinking about that mindset of just trying to influence people and how much automation and AI is going to make that happen. Keep in mind that's happening online to your applications. The number of people who have the skills to actually break applications is not as great as the number of automated bots that are out there scanning things for common security problems. When I mentioned earlier about the 3 R's, rotating your credentials, one of the number one ways people get compromised is they put credentials in their Git repo and somehow it gets deployed into production in a way that's actually visible. And people leak their credentials on a regular basis. So having the ability to quickly change that and fix that is going to be important. As far as being scanned and people attacking you, if you just turn on, like I have a test application I turned on the other day, I was testing something, and you just leave it on for a day, I will get 10 or 15 random machines scanning that website. The ability to scan the entire IPv4 space. There are presentations that I've seen people give that they'll be up just on stage for 45 minutes to an hour. And in that time frame, they've scanned the entire IPv4 internet space for a specific service across the entire internet in less than an hour. Wow. So the idea that people are able to find cameras, they're able to find certain configure, so if there's a known thing people do wrong, so say you end up using Steel Toe or Spring for your frameworks, or you're using Tomcat or whatever your favorite, say you're using Tomcat, that's a great one. The Tomcat administrative server is on by default on most deployments, or the path to get to the documentation. There's various services that come within Tomcat, and an indication to an attacker that someone is not hardening their environment is they don't turn those default things off. In production, you wouldn't have access to Tomcat documentation. It shouldn't be there. It's not your business to serve that. So what people will do is they'll set up a little bot that'll scan the internet once a day for any site that has that turned on. And then they'll have another bot, they'll scan the site that's associated to it and see, is it a business or is it just some testing or it's just, whatever it is. Now there's multiple reasons people are attacking. One is there are people looking to gain access to servers or systems for using them in bot networks to do more scanning. They're selling, there's a whole market of people selling scanning bots and results and details around that. There's people who are actually trying to, patch them and help people get better security. There's a whole white hat and environment where people are trying to help make things better. And they're scanning on a regular basis, university students or people in their own labs testing things. It's actually a good way of making money. There's a lot of bug bounty programs. You can make good money doing that. But there's also people who are trying to maliciously attack you, trying to gather your corporate data, trying to gather your information, your customer data, your credit cards. And I don't know of any enterprise out there that does not accept the fact that it's not a matter of if, but when something's going to happen. So part of that whole planning process I talked about earlier was making sure you know the ramifications of your space. And part of that goes with it is, what do you do when things happen? When you're actually observing things and you get attacked or someone calls up, you get a call from your bank and they say you've been compromised and your credit cards have been all compromised. What are you going to do? What is your response plan going to be? And that's part of that planning process. You can't design it after the fact. It's like the idea of pandemic planning, but you don't do it until like the pandemic hits. You have to plan in advance. You have to actually prepare and not just test and model. And this is actually one benefit to the pandemic is a lot of risk departments and companies have come up with these scenarios where they'll do what's called tabletop testing, where they'll once a year go through dozens of scenarios saying, if this happens, we'll do this person's called, and they'll have their lawyer on the phone. They'll have, maybe in a conference room with the operations team, the marketing team, the PR, all the different teams in the company. There's a certain response and preparation you have to do and plan for these things. And because of things like the pandemic, people are realizing that these once in a lifetime events really happen, and that it is something that you need to plan and prepare for. So if you are going to run a service that's a web-based application, be it a back-end service and that's an API and the front end's a mobile app, or it's just a web application it's available, you need to prepare for the fact that at some point it will be attacked. And what are you going to do about it? It has to be part of your business plan. If it isn't, when things happen, your customers and those who want to support you are going to question what your plans are.
Gotcha. Okay. Yeah, I think us that don't live in the web app coding and developing world, we don't really think about that as often. We just give things up willingly and just assume it's taken care of. So it's good to know there's people like you that are making sure that web applications are secure and they're fighting against hackers and bots trying to collect that information. For sure. Well, Lou, do you have any more questions?
Well, I'm good mostly. I just wondered, what's the give you some example. What's the customer engagement like? Meaning, how do they know they would need you, right? I guess for a smaller project, they will hand it to someone and say, oh, do this project for me. I want to be secure. It's your job, and how when do you coming in? And or I imagine there was a more high stake project, right? Banks and you said port, maybe defense, intelligence, that kind of thing, right?
Well, just about everybody's going to need to have this, and VMware isn't the only company that provides services in this space. I don't know what the size of the contracts and companies and customers are. The ones I work with are global companies, so it's not your typical startup. For the startup space, is engaging and getting started in this. That's the hardest part of being in the Southeast is there's only a handful of companies. You get on. There are firms in the area that can do development management. We have folks who built out great infrastructure service offerings in the area. But there's also a lot of people who have gone mobile and online these days. There's a lot of firms who are, I worked with a great firm in New York when we were trying to work on a banking app before that. They've, there's a lot of people out there in the metro areas or all around the world who you can actually turn to help you build and design these things. But it's building an application is not going to be, it's like starting a company. It's not going to be inexpensive. Starting McDonald's, you need about $1 million to get a McDonald's franchise together. getting an application off the ground, getting a business off the ground, you're going to have to, fund the development, fund the design work, the actual marketing, the logos, the ideas. You can do a lot of things relatively straightforward, but it does take, I don't think I've seen many engagements that are in the less than $40,000 to $100,000 range just to get started in the conversations. It's like any start for a business. But if you're going to get started on this yourself, there's a lot of references that I can probably share that can go onto the Creative Coast webpage on the agile process, the extreme development. There's some great books. There's some great ideas you can read if you want to understand how these processes can work, and then you can apply them to the ideas and businesses you want to create and see how those fit together. But as far as firms, there are firms here in Savannah. I'm sure we can get a couple lists for those together. There's definitely a bunch of them in Charleston. And if you want, hit me up on Slack. I can make some introductions to people for you if that's helpful in any way.